I'm Art Leverman, Vice Chairman of the group. Bob Way, our Chairman, is not able to be here this evening. Also, if there are any of you who are not SBE members, we'll put the pitch out. I've got a couple of application blanks with me. I'm glad to get them. And other than that, I think we'll just turn things over to our hosts and let us get on with things before it gets too late.
My name is Larry Sample. I work here at National. I work in the Linear and Integrated Circuit Department. I've been working on an AM stereo decoder for the last 9 months to a year. I intend to give you a distorted or prejudiced picture of AM stereo. My position is that of a component manufacturer. I don't care anything about how hard it is to transmit or that end of the business. I'm trying to make my job easier. I have to build components for radios, and a large part of our market is the automotive industry, specifically Delco, Chrysler, and Ford. So their requirements become my requirements. So I look at the systems with a jaundiced eye, that of how do I interface with that system to make it most easily. It's the function of the FCC to judge the Q of each system, or the merits versus the cost. You pick the one. I don't pretend to know what the FCC is going to do, but I can tell you, I can give you a description from my standpoint, that of an IC designer, which system I want to go. But probably the first question that comes to mind is, who needs AM stereo? That's normally the first question I get asked. What good is it? AM sounds so bad already, we use stereo, so it's not going to be any good. Well, from my understanding, most of the pressure for AM stereo on the FCC comes from the National Association of Broadcasters. The AM broadcaster people want to get back that market share that they lost to FM when FM went stereo. From the literature I've read, FM, before it went stereo, had about 3 to 5% of the market. And today, FM has on the order of half of the market. So the AM people view this as an opportunity to regain market share. Some of the technical reasons you might want AM stereo are that probably AM stereo makes sense in an automotive environment. It should be subject to less fading or less picket fence effect that FM has. The quality is probably that of a cassette or 8-track. And in a car, it could be argued that you can't hear the high frequencies anyway because of the wind noise or whistle. So AM stereo is a good fit. Now, there are 5 basic proponents. Now, these are the major ones. If you go back to Washington and read the docket like I did, you'll find that there are about half a dozen off-the-wall systems being proposed by somebody in Keokuk, Iowa. You know, they sat down and they thought about it and they decided how to do it, and they sent in a letter with a block diagram that this is how you really ought to do AM stereo. Now, I haven't taken any data and I haven't built anything up, but why don't you try it out? Well, realistically, the FCC is not going to do that. They're going to go with one of these major 5. Which one? I don't know. I can describe the 5, but I have no idea what the FCC will finally end up doing. The systems break down into 2 types. There's quadrature type, where they deal with the phase shift network, or the mixed mode type, where they use the conventional AM plus FM or phase modulation PM. I'll describe the decoders in those 2 types because that makes the most sense from my standpoint in building a decoder. All of the quadrature systems are somewhat similar. They have somewhat similar requirements. And while a single decoder could not be used to decode all of the quadrature systems, a decoder for those quadrature systems would be similar in nature, or at least in block diagram form. And likewise, the mixed mode systems, a decoder for those systems would be similar in type or function. So from my standpoint, there are basically 2 types of decoders necessary. Motorola has the C-QUAM, compatible quadrature AM. They take, the green shows what you now have, and the white shows what you're going to have to add. In the Motorola system, you matrix and generate your difference audio and your mono audio, the left plus right. You take your carrier frequency, 1 megahertz or whatever you happen to be, and you modulate that with a standard mixer or balanced modulator. And you also phase shift the carrier and modulate it with the left minus right signal. So now you've generated two double sideband suppressed carrier signals, here and here. One is modulated with left minus right, one is modulated with left plus right. These two are summed together and then limited. Now you notice in the summer there's also a line coming straight off of our carrier. And that's caused because in a double sideband suppressed carrier system, if you have no modulation, you have no carrier. And that's not the case with AM. You don't want that. So they slip a little bit of zero phase carrier through here so that when you stop talking, you still have some carrier to get amplified by your limiter. And after you've limited it, now you have a RF frequency that has phase information on it. The phase information is a function of left minus right, left plus right, and the two phases of the carrier. Then you amplitude modulate again to maintain compatibility. Now you notice stereo pilot question mark. In the Motorola system, there is a stereo pilot, but it's a little obscure. And for that reason, they chose not to put it on their block diagram. All of the block diagrams and so forth that I'll be using came strictly from the literature of the manufacturer of that system. So they chose not to clutter it up. And that's a portion of my problem. My customers, the car manufacturers, Delco, Chrysler, they told me that they want an AM stereo decoder that has one, fast recognition. They want to turn on the stereo light quickly. Quickly is 100 milliseconds or less. Secondly, they want absolutely no flicker of that light. Once it is in stereo, they want it to stay in stereo. And if it's not sure, they don't want any flickering. They want it to be in stereo or not. And thirdly, they want no clicks or pops or gurgles or bumps when it goes from mono to stereo. Now the stereo pilot in the Motorola system is stuck on this phase, but there's not much of it. And it's hard for me to detect that stereo pilot. It's hard for me to decide in the Motorola system whether I'm in mono or stereo. And in the case of all of these systems, I can make them work. You know, I can build a decoder, and I have built a decoder for 4 of the 5 systems. And the signal handling capability of those systems is not the difficult part. The signal path is easy. But when I have to turn on the light, turn off the light, maintain separation, that's the hard part. It's the more or less the peripheral portions of the system that is difficult for me. The signal path is the easy part. The Motorola receiver makes use of a phase lock loop. They use this to then synchronously detect the audio left and right. Now they do this after they've gone through a few phase shift networks. And shown here is an in-phase detector and a carrier level modulator. Now that is a function of maintaining low distortion in the stereo system. Motorola could do without that cosine corrector, but you would end up with a little distortion. The reason it's there is because Motorola chose, in their words, to put the pre-distortion on the stereo signal and not the mono signal. So the end result is they have a pure mono signal, or on the old type receiver, your present mono receiver in your car, you won't have distortion if a Motorola system is chosen. The Harris system is similar to that of Motorola, but they chose a different phase angle. They have plus or minus 15 degrees or 30 degrees phase shift between the carrier, rather than the 90 degrees used in the Motorola system. Now, since Harris manufactures transmitting equipment, they chose to show their block diagram as they would build a little black box to insert. They show a right and a left going in rather than an audio matrix of left plus right and left minus right. Now, the literature says that any one of the 5 systems could be implemented on an existing transmitter with the addition of some sort of black box, as yet undefined, or defined separately or differently for each system. The price of this black box might be $3,000 to $5,000. That's what the literature says. Once you take your carrier, phase shift it, you put the right over here, you put the left over here, and add the 2. Now again, they slip in a little carrier at 0 phase because at no audio input, you would have no RF output, and that's hard on the flipper. So you need a little RF sneaking through. C-QUAM means compatible phase matrix, multiplex. I call it C-QUAM. Okay, in the Harris system, they've got an envelope detector. So this is how we pick up our left plus right, and we don't have to matrix it outside the box. And then you go through a low-pass filter, and you conventionally modulate your transmitter. The clipper here is the same carrier, or the phase information of these two sum signals. Again, the stereo pilot is not shown. It's a little hard to stick it in there. Stereo pilot is on the left minus right phase, and as you can see, that doesn't exist explicitly in our block diagram. This is a vector diagram of how Harris handled it. They have 30 degrees instead of 90 degrees. Here's the stereo tone at 2.5% modulation. Now again, that's not much stereo pilot. I have a hard time detecting that. The advantage of the Harris system is the narrow RF spectrum. If you were to take all 5 systems and modulate them with a given audio tone or set of tones and compare them to existing AM signals, you would find that the Harris would most closely match existing AM conditions. The others would be wider in spectrum occupancy. Now, the claim is that all 5 systems meet the present FCC requirements for occupied spectrum. However, with the other stereo systems, other than Harris, you would certainly have a more sideband, so more interference. But that's not without a penalty. There's mono distortion in the Harris signal. Now it's not much, but 3 to 5% under certain extremes of modulation. But that's one of the penalties. So if you, in your present AM radio, if we were to adopt the Harris stereo signal, you would pick up a little more distortion than you have now. The other distortion, or the other problem with Harris, is the reduction of stereo coverage. Now that can be stated in 2 ways. Since they chose to limit the spectral occupancy, that there's less energy out there. So if you wanted to maintain the same signal-to-noise ratio in the receiver, you would have a reduced stereo coverage from your mono's coverage. And the Motorola literature claims that that would only be 16% of your mono coverage. Another way to view that would be at the outer edges of your mono coverage, you would suffer a 12 dB signal-to-noise loss when you switch from mono to stereo. In the Harris receiver, again, they have the phase lock loop, and they phase shift at 90 degrees. Over here, we detect left plus right out of a synchronous detector, and as a result of the phase lock loop, we get left minus right from this synchronous detector or phase detector in the system. Matrix the two, and have our left and right audio. This phase lock loop is not an easy portion of the circuit. Now everybody knows that phase lock loops have been around a long time, and there are standard techniques for handling them, and that's all true. But all of the quadrature systems, that is a non-trivial portion of the circuit. In order to maintain good separation, low distortion, you need say a 5 hertz low-pass filter, as pointed out here by the Harris system. Now, in order to get a 5 hertz low-pass filter, that's a long time constant. So as you're tuning across the dial, it takes a long time for that loop to lock up. And then once it's locked up, then you have to decide whether it's in mono or stereo. So in order to get around that long lock time of the loop, there are techniques, Diddler oscillators, dual load loops, and so forth. But those are complex circuitry. It can be done, but it complicates the issue. Now, the Kahn-Hazeltine system also needs here's the transmitter. Now they chose to phase shift the audio rather than the RF. This is ISB, or independent sideband. This system, this was proposed a long time ago, maybe 20 or 25 years ago, by Leonard Kahn. The right signal is on the upper sideband, and the left signal is on the lower sideband. So the crowning glory of this system is that if you take 2 mono receivers, tune one a little higher than the carrier, tune one a little lower than the carrier, you can get 9 to 10 dB of separation. So that's AM stereo right off the bat. You don't have to go out and sell any more hardware. Now, I have not built this system. The reason I haven't is that the literature is so obscure I can't decide how to do it. He's got a second harmonic component circuit. I've been unable to sort that out. And his limiter and his X translator here are a mystery to me. Based on comments from Motorola that I shouldn't even worry about this one anyway. So frankly, I have not given this one as much research as the others. But also the literature is a little more obscure. Now in his receiver, one of his blocks is merely a phase lock loop. So he's got a phase lock loop, and in the other diagrams that represented 3 or 4 blocks. He's got an inverse modulator, which was just the opposite of what we had on the last slide that wasn't detailed. There's a synchronous detector and some phase shift. And there are a couple of audio phase shift networks. So I have to phase shift the audio, a constant phase shift over all audio frequencies. Now again, there are standard techniques to do these things, but that's complex circuitry. From a receiver manufacturer, that means I have to buy precision components, 1% resistors, 5% capacitors. And admittedly, from their documents, this is the most complex decoder. But they said, don't worry about it. People who manufacture ICs can do magic things, and they'll do it for almost nothing. and there's no stereo indicator. Now, in his patent, he has a stereo indicator. Again, it's a little unclear as to exactly how to do it, but he talks about it in his patent. But in his proposal to the FCC, there is no stereo indicator. So that makes it hard on me. And the mixed mode system, Bell R, is the old RCA method. This is AM plus FM. Again, the green is the existing transmitter, and the white is what you'll have to add. They show a left and a right being matrixed to generate left minus right, left plus right. They put a 1.2 kilohertz preemphasis FM modulator and standard AM modulator out here after they've amplified it. Here's a carrier waveform of the amplitude AM and the FM on the left minus right. Now, in all of these cases, we try to maintain mono compatibility. That means we try to maintain operation with your old standard receiver. So that means that the envelope has to pretty well remain constant in all cases. You really can't monkey around with that. So what's left is that you can play with the phase in here, or frequency. So if you were to take a spectrum analyzer or a receiver and look at the IF waveform, you really wouldn't be able to tell which system you were looking at. They would all look about like AM on the top, but no telling what they were doing in the middle. So from that standpoint, the systems are all similar. Now, Bell R has no stereo indicator, none at all, and mono distortion maybe is overplayed. Under certain certain modulating situations, you will have high mono distortion on your Bell R system. The advantage of Bell R is the most simple receiver. Since they don't have a stereo indicator light, you don't have to worry about detecting anything and turning on your light. And the FM section is a well understood basic technique. You have a limiter, a discriminator, and the emphasis network, and then a matrix. The Magnavox system is similar to Bell R, except it's phase modulation instead of frequency modulation. And they put a stereo ID tone in. 5 hertz, FM the carrier, and then you left minus right, you phase modulate the carrier. Left plus right goes to your amplitude modulator and onto the output. Magnavox also claims that with this stereo ID tone at 5 hertz, you can put a Manchester code on there, which means it's a digital technique whereby you can detect or send information with the carrier containing the block. What that means is with a proper detector, you could, say, display your call letters on some LEDs, on some alphanumeric characters. Or you could put stock market on there. Or you could put temperature on there. Now the fact that they do that gives me fits. That 5 hertz is hard enough to detect as it is. But when they start putting a digital code of some kind on it, it really makes it difficult for me. Here's the Magnavox carrier. Again, the left plus right is on the envelope, same as it always has. And here they have phase modulation with a 5 hertz stereo tone ID. The Magnavox system uses a limiter and phase detector, and a 5 hertz detector just to turn on the stereo light with a matrix and then a switch to decide whether you're in stereo or mono. My objection to the Magnavox system is that 5 hertz is slow. Delco wants me to detect stereo in 100 milliseconds, and that's pretty hard with a 200 millisecond time period. If in order to maintain noise immunity, you detect 4 or 5 time periods before you turn on the light, that means it takes me up to a second to decide whether this system is in stereo or mono. Now, the final question is, who's going to win? When will it happen? The Harris literature says probably this fall, late summer, early fall, there will be a notice of proposed rulemaking. Now, it's unlikely the FCC would stick their neck out and choose one system. They'll probably eliminate one or two, so you'll be stuck with 2 or 3 systems. Now, I told them the least you can do is limit it to one generic type. You know, either throw out the quadrature systems or throw out the mixed mode systems. That would make my job a lot easier. But I doubt if they'll even do that. So there'll probably be 2 or 3 systems, maybe even 4, for reply comments and then counter reply comments, and then they'll go away and study it again. And then, you know, in 4 to 6 months after that, they will probably come out with a decision. And then there might be a court suit after that. But possibly by 1980, somebody will be transmitting AM stereo. Now, if you're looking at when will receivers be available, I'm going to try to be there with a decoder within a few weeks or months at the most after the FCC decision. So the question is, how long will it take receiver manufacturers to tool up and to build something using this new integrated circuit? The car manufacturers have a design freeze by November. That means by November, they know how to build the radio for next model year that starts in September, October. So if the decision is made in the spring of 1980, it will be possibly we can get in model year 82. And that's my side of AM stereo. The light's on. Any questions or refinements you'd like me to make or try?
Can we just stick out your neck and say, have you listened to the different systems in operation?
Yeah, I've got some off-the-air tapes.
I mean, which one do you think sounds the best? And empirically, without making any measurements. Do you want us to ask the hand Harris rep?
No. I would say, I haven't heard Harris, so I can't comment on that, on the Harris system. I have strong signal conditions and weak signal conditions. Now, bear in mind that I have three systems that were tested by the National AM Stereo Committee. So I can only comment on those 3. Those 3 on strong signal conditions all sound the same. They all have fine separation. They all have more frequency response than I can hear. On weak signal conditions, I may be listening to the clever receiver designer and not to the system. But on weak signal conditions, Magnavox sounded better. It had less adjacent channel interference. You know, you can listen to it, and it was hands down Magnavox. Now that may be because they chose to limit their bandwidth. They had a switch, wide bandwidth, narrow bandwidth. And in the weak signal conditions, they went to narrow. Still sounds pretty good, and there is certainly far less adjacent channel interference than on the other 2. But that may be hardware and not system related.
Are these carefully controlled conditions as far as the tapes are concerned? That is the adjacent channel signals. What is the ratio of the signals, for example? You know, from the received signal in stereo to the adjacent channels.
I have no idea. The 3 tapes or the 3 systems were done within minutes of each other, so they were all under identical conditions. Now, they were 300 miles away, and I forgot the name of the station. It's in some of that literature back there. They were tested in Bethesda, Maryland, in Washington, D.C., maybe somewhere else. I'm aware of those two.
Charlotte, North Carolina.
Okay. They told me that the strong signal was a very strong signal of 1,500 microvolts per meter, I think was the reading, almost overload condition. The other one ranged from, the distance signal or weak signal conditions range from something weak, like 10 microvolts, up to 500 microvolts. So it was significant fading in and out.
I was wondering about the splatter that we heard from the sidebands of the adjacent channels, whether
I have
it's 20-to-1 ratio or something like that.
I have no idea.
Okay, let me, the tests that were made, and this is why I think that you're really in a better position to evaluate. I understand that the tests were made, Motorola came in and said, here is our modulator, and their engineers fussed over it, and then here's our receiver, and their engineers fussed over it. And we don't really know what kind of black magic they worked on, the one-of-a-kind receiver.
Oh, absolutely, absolutely. Sure. I'm only familiar with the three in the test, and I've talked to all three of those people, those proponents.
Which of the three again now that you're familiar with? Which are the three that you're familiar with?
Magnavox, Motorola, and Bell-R. I've talked to Harris people many times, but I have not listened to their tapes. I built their system. Magnavox, Bell-R, Harris is going to suffer that 12 dB signal noise. No way around it. But it also has a narrow spectrum. You know, that's a big deal to you. It doesn't mean a thing to me. You know, I'm a receiver guy. I don't care what the spectrum looks like. Signal noise is a lot more important. But, okay, now, specifically in the tests, Motorola and Bell-R had antennas with amplifiers that they ran up on the roof and ran coax down the receiver. And when it came time for weak signal conditions, they put on one antenna. Came time for strong signal conditions, they put on another antenna. They went in and they soldered on the schematic and changed the insides of the receiver. You know, well, we can't tune that very well. Let's try this time constant. Okay, that's good. Let's go with that. That's specifically what Motorola did. You know, it's documented. It's in all the documents. So and this is a contention of Magnavox, that they were the only ones who had a production-worthy receiver suitable for consumer use or consumer pricing. They contend that the other two were just obviously laboratory curiosities. Certainly they work. You know, they have excellent distortion and separation curves, but it's Magnavox contention that only Magnavox has a real consumer type receiver.
That could be a question of that they just had somebody to put something together that worked in the first try, and Magnavox hasn't quite gotten it down yet. Well, I mean, by the time the FC makes up his mind, Motorola might have got it not only working but better.
Certainly. You know, that's why I say there's. I don't believe that further testing is going to prove anything. It'll prove who has the most manpower to put to the system or to develop that one receiver we're going to judge everything on.
Okay, I'm playing devil's advocate. You then have. So in order to decide whether you can design a receiver decoder of some kind, you must have built then the encoders for it. So you have got some kind of a brass board model so that you can make whatever system that exists. Do you have any feelings on which one is easier to make and keep working? On the encoder? I mean, not being the guy that originally designed it, took a block diagram and make it work.
Well, that's what I was. I took their block diagram and had to make it work. They didn't tell me how to do it. I had to take their block diagram. My approach is probably totally different from what you would do, or how you would have to maintain equipment. Incidental PM is a problem on all systems. It's particularly a problem on the Magnavox system. They've got a 5 hertz stereo indicator tone. If you've got 5 hertz of incidental PM or something that's in there wiggling around that many radians, you're going to cause me grief. I don't know which one is going to be easier to maintain. I have no idea.
When they adopt it, all of a sudden all the manufacturers are going to have to make something like that. It'd be interesting to see which one is easier to get into the transfer end of production.
Half an hour, or an hour, they were able to disconnect here and hook it in here and turn it on and play. That was their contention. I don't know the answer to your problem.
Which is the cheapest receiver? The liquid receiver?
Okay, we wrote to the FCC and we told them the mixed mode systems, the ones without the synchronous detectors, are obviously cheaper to build. So that means that Magnavox and Bell R would be less expensive from a receiver's point of view. The Magnavox system already has a stereo pilot tone for me to decode and decide whether I'm in stereo or not. Now, Bell R does not. The FCC could choose to add one. It's not likely they will, but if they don't, I've got to trick it out somehow. I've got to find something in there that I can decide I'm in stereo. Because my customer Delco absolutely told me, don't bother to come in here without a stereo light. You know, don't even bother to talk to us. You've got to have a stereo light. So, sure, you know, they're my customer, and they're right.
I work for a station which plays no record newer than 1948. They insist that the stereo pilot be on at all times because they feel that customers, their listeners won't listen to them unless the stereo light is on. Even though they're playing records that, you know, I mean,
They've got a stereo only.
Yeah. In fact, I could dump the stereo generator and just build a pilot generator and meet the requirements. So I can see why Delco wants that.
Okay, so from my standpoint, Magnavox is the cheapest system to put in a receiver because it's simpler than a phase lock filter.
Could you review or maybe compare some of the specs? You're talking about better distortion or worse distortion. What kind of numbers? And separation also. What kind of numbers are you talking about?
Okay, separation, they've all got more than you can listen to. You know, they've all got lots of separation.
What do you consider lots?
40, 50 dB. Is that lots?
Yeah, that's lots, yeah.
Yeah, I have built an encoded and decoded system. You can't imagine how hard it is to work with no equipment. You know, I have to build my encoder, and I've got to build a decoder, and then I've got a problem. Now, is it over here or is it over here? So that's very frustrating. I wish it's 5 years later somebody done.
Why do you have to build your encoders? Why not go to Magnavox?
I have.
And they don't want to give you one. Thanks a lot. They don't want you to look inside and find out what the secret is.
Motorola has its own semiconductor division. They won't talk to me because we're going to eat alive.
What about what about Magnavox?
Magnavox is seeking to protect themselves. If I build a very cheap decoder and I sell it to Fisher or Machusta or Sansui, who's coming after Magnavox, then they're not any better off.
Khan's the only safe person to deal with.
Well, Khan doesn't understand my business. Yeah,
The system keeps changing every time in front of the FCC.
he's
It also has been working for a long time.
To your knowledge, has there ever been a con system built?
Yeah.
absolutely,
Yeah.
absolutely. The guy must have done something.
One of the Mexican stations did it for a long time.
Yeah,
Clinton had a couple.
Exerta or something like that. You know, I've got probably a foot of literature back there. You know, if you want to thumb through it.
Is there any sort of a general trend, your client Delco, for example? I think one of the things that has concerned broadcasters for some time, AM broadcasters, is that we have, for many, many years, transmitted information that the average receiver couldn't capture. We've done a much better job sending out the signal, and the receiver industry has done complementing it with the receiver that has good bandwidth
Absolutely.
characteristics.
Yeah, I agree.
Is there a general trend of any kind in the industry to change that?
No. Not unless they're forced to. They will when they go to AM stereo. They will be forced to do that.
Well, it is likely that this will have a positive.
My educating the receiver people, my single comment is their opinion, or you know, from my perspective, those guys are all out there saying, well, I've got this FM receiver, you know, typically an LM3089, and it goes into an FM decoder, and I get out 2 slots that go to my audio. So now I have my AM, and I'm just going to stick that in my AM decoder and go to my 2 audio spigots. No way. They're going to have to go back and redo that whole AM. They haven't thought about that until I tell them. And then they say, why? And I point out, well, what's your bandwidth now? And what's your AGC look like? And, you know, what is your distortion? You mean, you know, you're going to try to tell me you want a 1% decoder, and you've got a 5% now? You know, let's get realistic. So
They really don't want to hear that.
well, when you say they, corporate-wise, you're probably right. Individually, the guys out there doing the job generally do. You know, they want to do a good job. They're not satisfied with doing a sloppy job like you've been doing. You know, they get whipped over a 10th of a cent resistance like that. So they are interested in improving the quality of things. Murata's working on ceramic filters. We're going to have a wider, low phase distortion ceramic filter, wider, you know.
So then a real tangible benefit from stereo, quite apart from stereo itself, might be the general improvement of the receiver.
Absolutely. You know, go out and buy an expensive component receiver. It's got 0.002% distortion and listen to the AM. Certainly not the broadcaster's fault.
I get the gnawing feeling that somehow like Delco has an awful lot of control somehow on that stereo pilot. I'm just kind of sensing that cost is the most important factor in building a good quality receiver, because we're talking about simple receivers, and by going to something like a synchronously tuned receiver, which is admittedly more expensive, you don't have the benefits of much better performance.
In the limit, I'm not sure that's true. I'm not convinced that a synchronous receiver is all that much better.
Product detector.
Right, or product detector, yeah. I'm going to have to spend a lot of effort to get rid of the whistles and clicks as you tune across, and the phase pops in and out. You know, I've got to detect that, turn on the audio slowly. There's a lot of subtleties. You know, as I said, the signal path is the easiest thing for me to do. Satisfying my customer or building a radio that any of you would want to listen to is much harder.
Isn't most of the cost, though, of the final chip, and this is showing ignorance maybe in the industry, but isn't the cost of final chip making the first one, and beyond that point, all chips basically cost about the same amount?
Within limits, that's correct, within limits. But these are all, in relative terms, these are all complex circuits. For example, the Motorola system may require 2 or possibly 3 ICs. I can do Bell-R and Magnavox in one, duck soup. It may require 2, or Han may require 4. Now, if they're all the same price, then that's 4 times expensive. Well, it's not quite that bad. But these are all getting large. We're all pushing the size limit. You know, we sell a lot of 50-cent ICs, but none of these are 50 cents. The prices we quoted the FCC were that the simpler systems would be $1.75, and the others would be closer to $4. And those are truthful numbers. Those are the numbers I
What
quoted.
really calls me, though, is that this is a receiver that they're going to stick into a car and they're going to charge you $300 for it.
More than that. There's some kind of multiplicity factor there. I don't know what it is. But another constraint in the car manufacturer is size. You can't, I go to those guys. I go to those guys, and I'm talking about doing something for them, and they're saying, well, now look, people haven't changed. If anything, they've gotten bigger. So the seat of a car hasn't gotten any smaller. The trunk, well, that's where they put the stuff. We can't make the trunk any smaller. And the engine's got more pollution stuff on it, so that's getting bigger. What's left? The dash. We're going to make the dash smaller. So Delco just went from a 2700 cc radio to a 1600 cc radio. Everything they've got is 1600 cc.
What are they 0 to 6?
Forward. Yeah.
Is there any constraint placed on the emphasis that we had now on positive peak modulation in the AM?
Oh, I meant to mention that. There's no problem with that. The problem is the negative modulation, when the carrier goes away. All of these systems have some sort of limiter. It's either in the phase lock loop, or it's inherent in the detector. So
When the carrier is completely cut off?
when the carrier completely disappears, they've all got a problem. And you can measure, you can say the signal noise increases at that point, and it's going to, there's a lot of ways to discuss it, but they all have a problem when the carrier goes to 0, because something is contained on that phase information that just disappeared. In all cases, that's all that's left. The amplitude's always there, so we can detect that and squirt it out, but there's something on the phase in all of those systems, because that's the only thing left to put the difference signal. So there is going to have to be a constraint. They don't tell you that. They tell you, no problem, just do whatever you want. But I imagine a 95% modulation is as low as they can go.
That's not a technical reason for supplier, that's just so the receiver can modulate, doesn't go berserk.
Yeah.
Doesn't unlock.
Yeah. Now, from my standpoint, I'm used to building FM detectors and limiters, and they have to have a certain amount of AMR, amplitude modulation or rejection. But my AMR number is referenced to a 30% AM mod. Now we're talking about routinely 90% AM mod in this case. So I have a far greater constraint on this limiter than has ever been thought of in the FM circuitry so far. So they just increased my problem by 20 to 30 dB.
We'll do it. How do you expect to solve the stereo indicator light thing?
Which one?
Well, any of them. The Motorola or the Harris, for example, because they both use the same idea.
Yeah. It's basically a phase signal. It's down there, it's pretty deep, not much there. I will just have to build a very sharp 20, 25 hertz detector. That is too slow a frequency for a phase lock loop. The typical situation now is they phase lock to 19 kilohertz. Well, it takes so many cycles for a phase lock loop to lock up. And so many cycles at 20 hertz is too many seconds for me. So I'm going to have to build probably a digital filter that either times or counts edges. And if I get one every 40 milliseconds, well then I know that must have been 25 hertz and turn on the light. It's a tough problem. You know, it's inherent.
That sounds like a difficult part of this design.
Right now, the stereo indicator light is the hardest thing I've got to do. But I attack the signal path first, and I was able to do that, you know, in a mere 6 months.
You think that it's absolutely a requirement that these radios have stereo lights?
Absolutely. And maybe 20 years from now, we'll all laugh at the stereo indicator lights. But
I don't know about that. I think that for the 99% of the people out there in the world without a stereo indicator light, they don't think that it's operating.
Why else are they going to pay an extra $100 for that radio?
It's a built-in ad.
Right. It's the same thing as KMPX. You know, why anybody they're listening to a mono record with the stereo light on, with all the other noise and garbage it does, they have to do that.
A question on the stereo thing, but in a different way. You mentioned that one of the systems, the pilot light that have modulation on the pilot fusion. Has anybody talked about the fact that a number of broadcasters use 25 hertz right now? Some models only support telemetry. I didn't know that.
Is that right?
Yes. Yes. Mostly the telemetry system. Well,
Turns out
Somewhat unsuccessfully most of the time.
no. I don't think it's 30 miles away. We use it day in and day out. Okay, and they use 25.
One of the people who contend they want to use 20 or 25 percent about that. Harris does that. What do you You ignore it?
I know nothing.
Still, he doesn't have to make it. Because that's what turned me on about the fact that
That was 5 hertz.
No, 5 hertz. But you were talking about, having the LED light up the cold letters. We want more, we want a meter that reads to the FCC to do something like that.
If you're going to go back slowly,
20 to 25 hertz. And so what we're doing is we frequency shift from 20 to 25 hertz. That's the way the current Mosley, system works. I don't know anybody that even uses that system for off the air. Do you?
Yeah, sure, you do too.
Well, isn't that area between 20 and 25 cycles?
I don't know. That's enough to confuse my
It's a lot of money. Yeah, it's to a 25, 22 to 30.
I'm talking about 6% return, AM return.
Yeah, right.
6%.
6% between 20 and 30 hertz.
I'll ask Frank Gilbert about that.
Yeah, because that is being used. Maybe not a lot of large.
It is not very
The only station I know around here that's using is KKIS. And they report serious problems. Are you using it?
Yeah, we're fine.
We're fine good.
Oh, yeah, 10 years. As a standard mode.
I believe that the,
Maybe your transmitter handles.
Well, they're going to have to decide not to do that, obviously. Somebody's going to give up.
Because you guys have information on that, and that's one of the best, like security of the transmitter and stuff like that.
Just think of it like FM quality giving up your STA.
John, are you using the amplifiers still?
Yeah, amplifiers.
I didn't say that.
you talked about high distortion.
It's quoting the competitor's literature.
The distortion of some of the systems under less than ideal conditions is in the 40-50% region.
Well, everybody's got a computer program, and they all ran their computer program, and they said, well, we won. And they all got their own.
Everybody's got a trade-off, I know that.
Yeah.
But in some of these systems, they
A
have...
perfect square wave only has 30% distortion. So if you had 40% distortion, that means you had to start notching out what you wanted. You know, the fundamentals you were after had to started to be notched out. Okay, I don't pretend to understand that portion of the arguments. I leave that to broadcasters.
Leave it to the federal government.
The thing that's scary is let the feds decide this.
You know,
Really, I think we're really making a mistake.
I went back there and talked to 5 of the commissioners and everybody on the technical staff that would listen to me.
Some new, something on the broadcasting magazine to the effect that they're going to try to limit the commission's authority, rewrite the Communications Act.
Right.
That's
What happened when you talk to them?
Those guys did not know anything about AM stereo.
They don't know how it works.
They didn't know who the proponents were. They didn't know any of the trade-offs. They had no idea which system was what. Now, what is going to happen is, it's going to hit the agenda. Somebody down there is going to decide, well, in the next couple of months, we ought to do something on that AM stereo. It's been hanging fire long enough. Well, then all those guys are going to rush in there to the reading room, digest all that literature, and in a 2-week period, write up something and hand it to the commissioner. And he doesn't know diddle. So he's going to read that and say, well, this is what my staff said. Okay, that's what we'll do. So that decision, I'm sure that's the way it's going to work. If you're Craig, and that is, there's going to be a decision made in a very short period of time, because they're not worried about it now because they don't have to. They're only going to do it when they absolutely have to.
Aren't they somewhat worried about making the same kind of a mistake they made when they first adopted the cause?
They better be.
Well, the way they talked about, I talked to Bob Orban about this at recently at NAB, and the way they adopted the FM stereo system was just a travesty. And it's just ridiculous. We could actually sit down in this room and form a paper, send it in, and have more impact than any other group in the country. As it is with rejected stations and petition to denies, you can do that with the FCC. They will listen because they don't know.
Yeah.
They really don't know.
So they're going to make their decision, and when the receiver people start working on it, there's going to be a hue and cry. If they make the wrong choice, same thing is going to happen. That's what happened in color TV. They made their choice. The guys who have to build receivers started working on it and said, holy cow, what did they do? And that, if they make the wrong choice, that same thing is going to happen again, because I can verify that nobody I know in the receiver industry is working on AM stereo. They're waiting for me to solve their problems. Delco, Chrysler, Ford.
Well, this situation with this mentioning Orban's thing, because he said that he does not believe that it will be wise, nor would the FCC ever allow a couple of test systems to go on the air like they did in Chicago with FM stereo, where General Electric and Zenith or something like that. Zenith said, we have 500,000 radios out there. You can't change the system now. What would you do to all those test people? And that's how we got FM stereo to essentially what happened now. They kind of forced the issue. So that won't happen. I think the FCC will be very cautious, and it will be years after you report it out.
I think, well, there's a lot of pressure for them to do something. And there's also a lot of pressure for them to do one thing, not to have a possible multiple solution.
They could also look at doing FM quad and hope it goes away.
I don't think it's going to happen.
I don't think they can.
I think
broadcasters are hurting.
Yeah, I think there's a lot of pressure back there.
The discussion, which is not your kind of thing, and it's not really our kind of thing, I think a lot of reasons why AM is clobbering FM, or FM is clobbering AM, is not because it's technical reason, it has to do with programming. Well, and that they're using engineering as a scapegoat, which is, we're sitting around here wasting your time with all these interesting things, and actually we're looking at a basic programming problem and not necessarily an electronic problem.
Could be.
I just wanted to toss a little comment out. I've been in Phoenix for a long time. We're a little plant and that's a lot of engineers over the world. And sort of going to your comments, but we were talking one time with one of the guys who was designing tuners. And said, why can't you guys come up with something that's a little better than what you've done out now? He says, I do every day. And we all sort of went back at it. And he said, my problem is this. He said, I'll design a tuner that'll do excellently. He said, I'll submit it. He said, management then comes back to me and says, hey, cut a buck out of it. And you start to think about that. You say, well, a buck isn't very doggone much. But when they're looking at it from the overall viewpoint, it does a lot of things. And it also does a lot of things to that poor guy who is trying to do the design work, because it makes a great deal of difference. And that, I think, is a lot of the reason why we're talking about lousy AM receivers.
In the FM area, I know that Delco is going to great pains to try to build a better FM radio. Money is not the real object at Delco. Space is a bigger deal than money. If I can save them a few square centimeters, I'm a hero. Delco has done some awfully innovative things in FM receivers, just for the car environment. They've got search tune radios that sometimes the FM signal is so strong that the search tuner will stop on the adjacent channel. Well, they've gone away and done a very special IC that merely is a center tune IC, doesn't drive any meter, just tells them whether the center tuned or not. So they've got a synthesized FM, they stop every FM station, and if it is center tuned, then they will stop there and listen. They do this in 100 milliseconds, I think, 50 milliseconds. And if it is not center tuned, even though they have a strong signal there, they keep going. Delco does things like hops in a car and sends 4 engineers to Iron Mountain, Michigan, because that's where the waves are a certain way because of all the iron in the ground. And then they'll go to downtown Detroit because there's this particular problem. And there's another particular problem in this. They send people all over. They spend a lot more effort to build a good radio than Ford or Chrysler. But the AM radio there is still an old design. There's a lot of room for improvement.
You talked about improving the front end of the AM radio because of the new constructions of the stereo. Did you see anything from the FCC, in other words, receiver criteria, how the UHF receiver?
People who demand the UHF stuff are the UHF broadcasters. So when the AM broadcasters get together and demand they build a better AM receiver, then it might happen. Zenith doesn't want to build a better UHF receiver.
The reason why we have UHF channel space is because the manufacturers of the FCC said we could not do it, when actually they could, they just didn't want to.
Yeah.
It took a big fight to get them to give you a UHF tune that actually went click, 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 and so they just kind of built for it.
And you built these systems, and you know that better than we do, that this is not going to make AM radio high-fi. This is the biggest sort of game that is being pulled on a lot of radio stations. They think that suddenly they'll have their chance at FM. And it's still going to be kind of a rolled-off medium with zippy 6kc response. That's about all you're ever going to get out of AM radio, unless you're going to suffer from an incredible amount of background noise. And people will not tolerate that. Listening tests prove that Delta was right. But you get into the broadcast area with this, our people here, and discover that, well, the management of the station is sort of under the impression that AM stereo is going to make them sound like FM. And boy, well, people better be surprised what's going to happen. The way we handle our limiting when going into the transmitter is going to be completely different with AM stereo than it will be with FM stereo. You would not sacrifice, you couldn't stand having 50% modulation on your station because of one channel. You would not accept that on AM. You need to hear the station.
Yeah.
But on FM, we do that. So we have a completely different approach to what is going into the thing that you're going to have to demodulate.
Just think about ADC's pushing the thing down.
We're going to have some sort of...
Yeah, I'm told Bob Orban, a discussion I had with him, he told me that limiters for AM are going to have to be incredibly complex devices that analyze the 2 channels coming in and decide the ratio between them, instantaneous phase relationships and everything, and make all kinds of adjustments to, you can't just take 2 limiters, strap them together, and stick them on the air like you do with FM.
You bet.
Or you can drop your audio to 50%.
Yeah, absolutely. That's right.
No one will tolerate that.
That's right. That's absolutely true. But that's an easy thing to do.
You're probably also I don't have to do it.
Well, that market doesn't interest me at all. There's only 5,000 AM broadcasters.
We're getting that picture slowly but surely.
What does the market look like for this thing? I mean, how much money is really out there? Because it's not going to be in the transmitting equipment.
Absolutely. Besides Delco.
Every stereo radio is going to go AM stereo. There will be no reason not to, because they've already spent the money for the speakers, the wiring, the audio. So every stereo radio is going to go AM stereo. In the automobile alone, there are 3 million stereo radios each year. So my price will be $2 to $3 a piece. Now you see, okay? And that's why I'm going to be first. The first guy out there is going to win. There's my counterpart at Sprague, Motorola, Signetics, Fairchild, TI. They're all out there too.
I was reading that there are some of the Japanese IC manufacturers who are getting ready also.
Yeah.
What do you hear about that?
You remember the name of that receiver? Sansui. Sansui has a stereo receiver with a switch with 5 positions on it. Today, you can go buy it. Um,
Gotta get up real early to beat the Japanese.
Delco buys American, fortunately. That's the, you know, that, frankly, that's the only radio market left in the States. I mean, just the car radios. Everything else made overseas.
Sansui has offered to build the Harris C-QUAM system, our stereo generators, our transmitter interfaces, and our modulation monitors. Already. I mean, they've already started.
Sansui had a proposal. You know, they had a stereo system before the FCC, and it's very similar to what Harris has. So they're more than prepared for that system, and probably the other quadrature system also.
Do you feel that the quadrature system just has to be the answer, really?
Quadrature? No. That's harder. That's more money. Long term, if we were starting over, quadrature is obviously the way to go, because then you wouldn't have to be compatible. It's obviously the way to go. But with the compatibility requirement, then that puts some added defects on the quadrature system. You know, a pure quadrature system makes all the sense in the world if we didn't have our old compatibility problems. But with those compatibility problems, then that adds complexity to the quadrature system to the point that I think the non-synchronous detector, non-synchronous decoder is cheaper enough to make it worthwhile. And that's the performance, the listening performance. I can't really tell a difference. Maybe a keen ear can. They all sound pretty good to me.
The system performance is kind of scary because you think about all the little building blocks and all of these. The building blocks that are on those diagrams comprise many of our lifetimes. Get those things to work. And there are some. It's a bandwidth limited medium.
Yeah.
It's going to be
Well, presently they have like a 2.5 to 3 kilohertz bandwidth. Now, if you open it up to 5 or 6, you're going to think that's a radical difference.
Hi-Fi.
That's hi-fi, yeah.
Oh, it's still the difference between FM and AM, though, so it'll be a difference.
Oh, yeah.
Sure.
Yeah.
Except once you've got to drive you crazy, you go back to AM.
Well, who cares about mono in that case? I mean, let's be serious about this.
In the home.
Only the FCC cares about compatibility.
Yeah. Yeah.
I mean, when we do station IDs on radio stations, we all know what radio station we're listening to. We're obviously giving the ID for the FCC's benefit. Or DX's benefit. But I mean, who cares about the mono listening anymore? Go try to buy a mono record player somewhere. You know, it doesn't
You want to
exist.
stare at 1995.
exactly.
Yeah, but you can only go to good places. I mean, I think
You're right.
We worry about this mono compatibility. And nobody's going to listen to mono if they had a choice.
Well, I don't know, I
Get in the same
radio.
In your home, FM will always win. If you have a strong FM signal, it will always win in a good listening environment. But if you live out in the plains of Kansas and there's no close FM station, then you're going to really enjoy that FM stereo, that hi-fi FM stereo. But there's not very many people living out there.
Yeah.
Can I ask a question on the receiver for a second? We were talking a little while ago about this bandwidth and everything. Is there any effort being done in filtering, in other words, in low-pass filtering, in the receiver end of it? I mean, one of the problems is the heterodyne, raised whistles, all that kind of thing. And in these new killers,
That's the answer, yeah. That's the answer today. That's today's answer. Now, they also have a 10 kilohertz notch filter.
that's what I was getting at.
The good receivers have that. The good receivers have
Would
it.
your design in the chip detecting and all that kind of stuff include that?
No, that's too many pins.
This is the dual line you're working on?
20 pins. And I use them all up. And I'm already at 2 packages on some systems. You can't multiply, so it's good. You know, 40 pins, the package cost start to dominate. I got to keep it cheap.
You can go into a square package instead of
Space is a big deal.
that's how a square package is made. You know, you just have to a square package.
Not here. Somebody may be.
Yeah, the way you're talking